I am going to share my screen with you. And Quay, I changed that slide during
I
our
didn't even see. I didn't even go hold you mistake. I was in the bathroom, so I
little.
didn't even.
I
I came back and the joint said the whole says removed. I'm like, oh, she lied. I had to go.
He's
Oh
so
shit.
silly. He's silly. All right, so ladies and gents, the class is applied math. Again, if you haven't enrolled in the class, there is the enrollment code. I think all of you have thus far. And I've also upgraded and given you the assignments. So they should be there. So today, our lesson is going to be comparing data representations. The objective is again to create graphic representations of data. That is the standard is the standard that the state of Pennsylvania says we must cover in this course. And the agenda, we're going to have our community meeting as usual. We're going to do a warm up. You are going to be graphing data in two ways. So you'll be graphing the same data set in a histogram as well as in a box plot. And then the lesson will be comparing data representations. And we will practice matching histograms to box plots. And then your assignment will be the second cool down, and it will be due by Friday. So let's see where we go, how far we get into this. So, community meeting. If you were given a chance to be immortal, would you take it? Why or why not? If you were given the chance to be immortal, would you take it? Why or why not? So you're going to live forever and ever and ever. You
Richard,
with?
was it a slide that we had to take notes of?
Pardon me?
I said, was it a slide that we had to take notes of?
Yep.
Oh,
But that's all right because you'll see it.
all right.
Anybody? Anybody want to respond to this question?
Yeah, no.
You said no. Why no? Why wouldn't you want to be immortal? You will be smarter than everybody else because you will have seen the old stuff and the new stuff.
Yeah, but I mean, no, because the one is just I don't like people. So for me to continue to be around people, I'm gonna have that.
Y'all kill me with that. I don't like being around people. What did people ever do? All right. Well, I mean, okay. You're not a people person, so this wouldn't be for you. Is anybody chatting me? Would anybody like to be immortal? Nobody
It
chatting me?
depends.
What does it depend on?
Like, I don't know. That's why I said that you gotta think about it.
Yeah, true. Now, if you're immortal, like I said, you will probably be one of the smartest people living because you know the old and the new. Okay, so that would be advantageous, right? Because let's say like right now, it is 2020, we are living through a pandemic. So, if another pandemic doesn't come, if it goes like the last one, another 100 years, because remember the last time it was in 19. So if in the next 100 years you wouldn't panic about being in a pandemic because you already been through one, and you know that there are certain things that are going to happen, but you can live through it. You know what I mean? So you will have that knowledge. However, you won't have your sibling. You won't have, if you, as you got older, if you had a spouse, you would lose your spouse.
I'm not going
You would lose your grandkids because you are mortal. So all of your whole lineage, ultimately, you would be the only one left. So you wouldn't have any of your family. You would have your family, but it would be, again, generations. It wouldn't be, you wouldn't have your parents, your grandparents, your sibling, but you would have like their children. And you would have like maybe you would see all of your lineage. You would see your grandchildren, your great grandchildren, your great great grandchildren, your great 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 grandchildren. You know what I mean? You would see all of those things, but ultimately you will be the only person left on your family. Every year, only you, only you, only you, only you. No, you wouldn't want that. You wouldn't have any friends your age, because again, you're immortal. So your friends have passed on, but you're still here. I think that's why I would not want to be immortal, because at some point I'm not gonna have anybody really to talk to, because everybody my age gonna be dead. So nobody will be able, I won't have anybody to talk about the pandemic of 2020 with. I won't have anybody who was there when President Obama took office. You know what I mean? I won't have anybody there to talk to me about the insanity of 45, because they all gonna be gone. So I that's the piece I think that would make me not want to be immortal. Because, part of living is being able to share experiences with people who share the same experience. You know what I mean? But okay. Anybody else? Immortal or not? Yes or no, and why? Okay. It's cool. It's cool. So if anybody comes up with something, you can always throw it in the chat, and we'll see, and I'll say it. So now, ladies and gentlemen, the warm up. So now, last week we talked about a histogram and a dot plot and a box plot. A box plot being the one that most people didn't particularly care for, but that's okay. So what I want you to do is I want you to use this given set of data, and I want you to construct a histogram and a box plot. So that means look back at your notes. That's why I told you, take notes. Okay, because in this virtual environment, notes are going to be very important. So look back in your notes. I want you to construct a histogram, and I want you to construct a box plot of this very data. I have 10:45, so I will give you 10 minutes. So at 5 minutes to 11, I want to discuss what you have. So again, construct a histogram and a box plot. I'm not having you construct the dot plot because there are no repetitions. So there is no variation in the dot plot. Take down this stuff. Make you see it. Did change the data. All right. Okay, I was getting ready to say, I'm going crazy. Let me see who on here should I be calling on these. Let me see what dance is. Good morning. How do we are working on the warm up. You are creating a histogram and a box plot of the same data set. Yeah, I just had to run up here. Oh, here you go. Wait, is that to run before I send him a message? Oh, that's hey Naira. What's up, boo? How are you, my love? Oh, okay. Yes. Okay. Oh, all right. All right. Okay. So, ladies and gents, on the immortal, we have one of our classmates believes in reincarnation. So, immortality is not necessary. Okay. I believe that kids, I don't know if I believe in reincarnation, but I do believe that like when somebody passes away, somebody is born, and I believe that that person who passed away, even if the person who was born doesn't know them, I think they get a little bit of their spice, a little bit of their characteristics. So I guess that means I somehow might believe in reincarnation too. But I do believe in passing on the genes, especially familial stuff. All right, we got about 5 minutes left, and then we're going to start talking about this. All right, ladies and gentlemen, anybody got some conversation? Describe to me your histogram. Some brave soul. What does your histogram look like? Ooh. Don't all fall silent. All right. So let's start from the beginning. So tell me, somebody, tell me about your bins. How did you group your data? And everybody, again, everybody does not have to have good morning. Everybody does not have to have the same size bins. But they shouldn't be too big and they shouldn't be too small. Because if they're too small, it's gonna just look busy. And if it's too big, you're gonna miss some of the data. The data will be absorbed. So, anybody, can you tell me at least, tell me your bins. Where did you start and where did you end? How wide is each bin? Because remember, your bin should be the same distance. Anybody? You know, this works on a give and take. All right. So nobody has anything to offer right now? Okay. But let's look at it then. Oh, wait, let me make sure nobody's chatting me before I start. Nope. Okay. So, ladies and gentlemen, a histogram is, again, akin to a bar graph, except it does not have gaps because the data is continuous. So we will see. Now, my bins, I started with the lowest number and I just went up 5. So each bin is 5 units apart. I started with the lowest number, 3. Now, again, you didn't have to say 3 to 8. You could have said 3 to 7. But then, because that's 4, you would have then had to go 7 to 11, 11 to 15, 15 to 19, and then 19 to 23. Okay? So, no, 19, yeah, to 23. Okay? So, again, your bins could have been any length, but again, not too big and not too small. So now, when we look at the bins, remember, the lowest goes inside the bin, the highest goes into the next bin. So looking at our data, which I put in numerical order, in the bin from 3 to 8, we count 3, 5, and 7. Because again, the 8 gets counted in the next bin. So in the second bin from 8 to 13, there are 2. And that will be the numbers 8 and the number 12. In the third bin that goes from 13 to 18 is 2 because you have the number 13 and the number 14. And then in the last bin from 18 to 23, you have 2 terms and you have 18 and 21. So remember, you organize your data in a frequency table or in a frequency table to help you do your histogram. Again, the frequency table organizes the data and then you graph the data. Okay, so the bins are across the bottom, and you see the endpoints, 3, 8, 13, 18, and 23. And each bar represents what is happening in that bin, okay, or in that grouping between 3 and, since all of these are whole numbers, between 3 and 7. Now, if we did not have the data set, we wouldn't know exactly which 3 terms fall between 3 and 8. We wouldn't know. We wouldn't know if it's 4s, 5, 6. We wouldn't know. All we would know is that there are 3 terms in the data set that fall between 3 and 8, or in this first bin. So again, the bins are at the bottom, and then the frequencies go up the side, and we see that this is what our histogram should look like for this particular set of data. If that is not what your histogram looks like, do a little sketch of this histogram and the frequency table so that you understand where the graph came from, because you will have to do this on your own. Okay, we good with the histogram, or I need to sit here for a minute? All right, and I'm going to add something to this real quick. Okay, so that's just a little reminder that the bins are equally spaced. Okay. Now, the dot plot. There's nothing going on the dot plot. There are no repetitions. So this is what the dot plot would look like. But the advantage of the dot plot is, even if you were not given the data set, you could derive the data set, without question from this dot plot. It is clear what the terms of we can tell what each term of the data set is. Okay, it is clear. And again, like I said, because there are no repetitions, there is no action on this dot plot. And lastly is the box plot. Now, we wrote down the 5 steps to creating a box plot last week. The first step is to put the data in numerical order. And for those of you who were not here, you might want to write this down. So the first step is to put the data in numerical order. And that is what we did in step 1. Step 2 is to identify the maximum and minimum values of the data set. So again, we see the lowest term is 3, the highest term is 21. In the third step, we find the median of the data set, and that is our Q2, or our quartile 2 marker, okay? So the middle of the data set. So we see the data set has 9 terms. So we come in 4 from the right, come in 4 from the left, and we find the median of the data set is 12. So now that the median has divided the data into 2 pieces, we go to step 4, which is to find the median of the lower portion of the data set. So our lower portion is 3, 5, 7, and 8. And again, to find quartile 1, we find the median. Oh, excuse me. We find the median of the lower half of the data. But we have an even number of terms. So how do we find the median when we have an even number of terms versus an odd number, where we can definitely decipher where the middle is? So what happens when we have an even number of data terms? How do we find the median? Don't all speak at once. Nobody remembers? All right, I want you to read the slide. So down in this lower left corner, when you have an even number of terms and you want to find the median, you find the middle 2 and you take their average. So for us, 5 and 7 are in the middle. We add them together and divide by 2. 5 plus 7 is 12. 12 divided by 2 is 6. So the middle of the lower end of the data will fall at 6. So between 5 and 7. Same thing in step 5, you now find the median of the upper portion of the data. And again, same thing. There are 4 terms there. So in order to find the median, we take the average of the middle 2. So we add 14 and 18 and we get 32. 32 divided by 2 is 16. And then we put in our values. So the box and whiskers starts with the minimum value. Then the middle of the lower end of the data, Q1. Then the middle, the median of the data set itself, that is Q2. Then we find the median of the upper end of the data, which we found to be 16, and our maximum value is 21. Now, the way that you draw the graph matters, okay? So, because the median of our data set is 12. 12 is closer to the median of the upper half of the data versus the lower half of the data. So you should have the median close to that end of the data. Okay, so let me stop this for a minute. So if I were to put this down here, that wouldn't be a proper graph, because I would still mark this 12. 12 is not that close to 6. Okay, 12 is closer to 16. So we moving on down here. Now, also on your whisker, 3 and 6 are close. So in essence, this whisker could be shorter. Okay, because again, 3 and 6 are close. Three and 6 are close, so your box and whiskers should represent that. So 3 and 6 are 3 away, whereas 6 and 21 are 5 apart. So they're a little, so this whisker should be a little longer than this whisker. Okay? So now, again, look at your box and whisker. If you did not get the box and whisker, then write down the steps and their responses. So first, you put the number in the data in numerical order. Second, you identify the minimum and maximum values. Third, you find the median of the data set. So of the entire data set, which will divide the data in half. And then you will find the median of the lower half, that is called Q1, or quartile 1, because you see that the graph is in 4 parts. So quartile 1 is the median of the lower end of the data. And then you find quartile 3, which is the median of the upper half of the data, and you have your 5-number summary. I will give you about 2 minutes to tighten that up, because then we will have about 6 minutes left. Now, can I move the slide? Is that okay?
Yeah.
Okay, I was gonna say your silence is consent. All right, so we had 3 representations of the same data. In the box plot, you could see each term without a doubt. Like right now, we don't see what the data set was, but if we needed to, we can tell from looking at the dot plot the exact terms of the data set. The box plot is a 5-number summary. So you can still find out some information here too. You can find out the range of the data because you have the maximum and the minimum. You can find, or you can say that 50% of the data, which falls in this box, is between 6 and 16. And you can also find, this is called the interquartile range. So you can also find the range of that 50% of the data. Okay, so we know the range of the data set itself is 18, but the interquartile range, the range of the 50% of the data is only 10. Okay, and we'll talk about interquartile range. We can say that the middle of the data, the median of the data is 12. Okay, so you can get some information from the box plot. And again, it is just a summary. The box plot does not speak to individual terms. Okay, like the dot plot. A box plot, again, is a quick summary. You just need to know what's going on with the data. And then lastly, a histogram. The data is grouped into equal bins or equal groups. And again, similar to a box plot, you don't know the exact terms that are in the data set. What you know is 3 of them fall between 3 and 7. 2 of them fall between 8 and 12. 2 of them fall between 13 and 17. And 2 of them fall between 18 and 23. Because we see 23 not even in our data set. Our data set ends at 21. So again, we don't know if we just had this graph what those 2 terms are, but we know that there are 2. Okay, so again, the dot plot shows individual terms. The other 2 don't speak to individual terms, but you still have an idea of what the data looks like. Okay, questions, comments, concerns? Okay. Since we only have 4 minutes, I am merely going to just introduce this first slide, and this is where we're going. This will help you with the cool down 2, because the cool down 2 is about comparisons and matching. So we will be moving to making comparisons. We will be comparing dot plots to histograms. And in our discussion, we are going to talk about the shape. Okay, so this means something. The way this box plot has been created, it means something, and it relates to this histogram. Okay, so we'll check max and mins. We see here the minimum is zero. So here that would be 0. But then here they tell us that the median is 3. So what does that mean for us? We know that 40 is here. 50% is the median. So that means something of this 10 of this 28 plays into the median. So you know the median has to be somewhere in this second tower, in this second bar. Okay. Now, according to the box plot, the median is about 3 because this is the median. Okay. So again, and then we'll look for outliers. We'll also talk about, again, maximums, minimums, but how they look differently in each and how you can tell which 2 go together. Okay, or which 2 represent the same data. So we are going to start our next class with another warm-up where you are going to be given a set of data. You're going to create a histogram and a box plot. Okay, and then we will move into making the comparisons. Okay, now I might change the deadline for the cool down. It depends, but right now the cool down is due on Friday, but we'll see. I could change it to next week. All right, so I will stop the recording now.